find the explicit formula. This time we're finding the explicit formula instead of the recursive formula. And you see over on the right side in that blue box, that's a formula for the explicit formula. And this is a little bit easier to deal with. It's a little bit better than the recursive formula. If you think about it, the problem with the recursive formula is to find the 100th term, you're going to have the 99th term, and then the 98th term, and the 97th term. And so it's kind of hard to come by the recursive formula because you always have to know the term right before it. For the explicit formula, we don't really care about the terms right before it. We still want to know an, so the answer is still going to be an equals, but this time it's going to be different because we don't need to know the bushel right before it, all right? So if you look at the formula in the blue box, look at what we need to know. We need to know the first term. Well, the first term is just 12 in this case, and then plus. Now, we don't know what n is. N could be 100, it could be 200, so we're just going to leave it alone as n in our formula. So n minus 1. And then the d number, we know about the d number, it's just how do we get to the next number? Plus 10, plus 10, plus 10. So that d number over here is 10. So we actually have our explicit formula already built. The rest of this is just we're going to simplify. So let's distribute that 10. And we would have 12 plus 10, n minus 10. And then look at your like terms there. 12 minus 10 is 2. 2 plus 10, n. So remember, we want an equals 2 plus 10n. That is a formula, an explicit formula for the nth term. That means if we wanted to find the 100th term, we would just plug in 100. And we could find it. We don't need to know the 99th term. We just need to know what n is. If I want to find the 64th term, I plug in 64. Got it. So we can do this over and over again. For the next one, an equals, the first term is going to be 24 plus n minus 1 times d. Let's see, how do we get there? Minus 7. Looks like times negative 7 right there. So again, we're pretty much finished. We just need to clean it up. So distribute the negative 7 there, and you have 24 minus 7n plus 7. And combine the like terms. 24 plus 7 is 31. So an equals 31 minus 7n. That's an explicit formula. Explicit formulas are very useful for finding a term off in the future, like the 99th term or the 57th term or whatever. So 15 is doing exactly that. Find the term named in the problem. They want to find the 26th term. So what you could do is say, all right, I see that first, second, third, fourth, fifth term, sixth term, seventh term. You can see that they're adding 2, and you could just add 2, add 2, add 2, add 2, add 2, up until you get to the 26th number, and that would work. I don't really want to do that, though. What I'd rather do is do what we just did, find that explicit formula, and then plug in 26. So think about the explicit formula. For the nth term, let's look at it again. You take the first term, so the first term is this 23, plus, think about the formula in that blue box, said n minus 1 times d, in this case was 2. All right, now this problem goes one step further because we know what the n number is. This is the n number, 26. So if we're finding the 26th term, we can actually go ahead and plug that in. Now, I'm going to do this part in my head because I know 26 minus 1 is 25. So we're going to have 23 plus 25 times 2, or 23 plus 50 is 73. So we've got a specific number this time, not a formula. The 26th term is 73. That means that's the number that would be in this box, or this bushel of apples. Number 17 is doing the same thing. So we can think about this as the 26th term equals the first term is 34. I'm just going by my formula. Plus n minus 1, or in this case, n minus 1. If n is 26, we can go ahead and say that's 25 if we want, times that d number. So the d number is how you get from here to here to here to here to here to here. It looks like plus 7. That d number would be 7. So we have 34 plus 25 times 7 is 209. Answer is 209. The 26th term, A26, equals 209. Now again, if you're confused, we went back and we used this formula. AN equals A1 plus n minus 1 times d. That's all it is. AN equals A1 plus n minus 1 times d. You're going to need that formula out, so make sure you write that down somewhere on your paper, because that's what I used. Number 19, the water level in a tank is currently 64 inches high. Water is draining out of the tank at a constant rate of 0.5 inches every 30 seconds. What is the water level after 15 minutes? So let's think about this as a sequence of numbers. It starts at 64, and then after 30 seconds, it's drained 0.5 inches, so it must be 63.5. And after another 30 seconds, it's at 63, and then 62.5, and then 62, and so on and so on and so on, right? Okay, so I'm not going to cheat and shortcut this because I want to know what happens after 15 minutes. So let's kind of jump over it and say that's 1 minute. It's going down 1 inch every minute. So 1 inch every minute, if you think about it. You're subtracting 1 each minute. Okay? So the shortcut of this is after 15 minutes, if you're subtracting 1 inch every 15 minutes, it's just going to be 64 minus 15, right? Okay, so let's think about the formula. Okay. The 15th term. Okay, I'm shortcutting this process because I'm changing it to minutes because that's what we have in this problem. So the first term is 64, and what I'm doing is I'm subtracting 1 n minus 1 times. And so if n is 15, then n minus 1 is 14. You're actually subtracting that number 14 times. Okay? So 64 minus 14 is 50. You can kind of test this out and say if this is the first number, and this is the second number, and this is the third number. To get to the second number, you subtracted 1 time. To get to the third number, you subtracted 1 2 times. And so if you got to the 15th number, you'd end up subtracting 1 14 times, which is what I did. What is the water level after 15 minutes? Looks like it's 50 inches.